So what we're going to do now is get comfortable converting from radians to degrees and degrees to radians. And we're going to use the relationships that we just discovered here, that at 1 degree is pi over 180. This is the one we're going to use for converting from degrees to radians. So in the first one, we're going to convert 45 degrees. Now we're not going to write this down every single time, but watch. If 1 degree equals pi over 180, then 45 degrees must be 45 pi over 180. Agreed? And now that's a fraction that we can reduce. So how many times does 45 go into 180? 4 times, so it's going to be down on the bottom. So that's 1 and 4. And so what we say is that this is pi over 4. Which kind of makes sense if you think of 45 degrees. 45 degrees compared to 180. 45 degrees is smaller than 180, so it's a fraction of 180. And in fact, it's exactly 1/4 of 180. So we could have written it like this. We could have said it's 1/4 pi, but we don't use that notation. We just sort of say it's pi over 4. So it's pi divided by 4. Okay? It starts to become more obvious when we get to easier numbers. But let's continue on and try it with 135 degrees. We're not going to write out this little if part all the time. What we're going to say is 135 is 135 pi over 180. And that's just a matter of reducing this fraction. So there's a couple of ways you can do it. I might see that they're both divisible by 5. So if what's 135 divided by 5? 27. So I'm just going to divide both the top and the bottom by 5, and I think that's 36. It might reduce even further. Do you see a number that divides evenly into 27 and 36? 3? No? Don't start just throwing numbers at me. How about 9? Yeah? Okay, there we go. So if you divide the top and the bottom by 9, it's 3 over 4 pi. And again, so now we write 3 pi over 4, but we understand that as 3/4 of pi. So again, if pi is 180, 135 is less than 180, but it's closer to 180, right? And it's 3/4 of the way to 180. So we write 3 pi over 4. You can, but you'll see that you won't want to eventually. Okay, this is common notation like this. Okay? Okay, so Dustin is saying that must mean that 90 is 1 pi over 2. Let's do it. So 90 is 90 pi over 180. And that's an easy one if you divide the top and the bottom. Now he said 1 pi over 2, which is exactly right. You can also just say it's pi over 2. And this is the one that makes the most sense to me. If pi is 180, then 90 is half of 180. So in radian, that must be half of pi, or pi over 2. So you're going to get really comfortable with these numbers. So for example, you can just say, okay, well, 180 is pi. Half of pi is pi over 2. What's half of 90? 45. And what's half of a half? 1/4. And so this is pi over 4. Okay? So you can start to make those relationships. We can do it with other ones that are not quite as obvious. So let's go down here to 225 pi. So 225 is equal to 225 pi over 180. Do some reducing there. I can tell you if you divide everything by 5, I think you get 15 pi over 12, and then divide everything by 3 again. It eventually reduces to 5 pi over 4. You might take a few steps to get to that, but it's 5 pi over 4. And again, let's stop and think about it. Pi is equal to 180. 225 is a little bit more than pi, right? So our fraction is going to be a little bit more than a full pi. Okay? And know that we also can have negative degrees in these. Whereas we didn't think of negative angles before, because in a triangle they're all positive angles. But if we're thinking rotations, what do you think a negative means in a rotation? Yeah, it goes the other way, which in that case is clockwise. So negative 150 is a rotation the other way. Okay? But for our purposes of conversion, it's still just negative 150 pi over 180. I can do a real easy simplification there and divide them both by 10 and get negative 15 pi over 18. And I think they both divide by 3, and I can get negative 5 pi over 6. Okay?